Good day, Teacher Ella here. Our topic for today is the solution as a uniform mixture. Let us brighten our day with this song.
Looking at this mixture, if you know that they're distributed, this uniform solution, the mixture, it is homogeneous with light, it ain't scattering, the particles are too small. Either way, in this case, those particles are dissolved. Looking at this mixture, if you know that they're distributed, this uniform solution, the mixture, it is homogeneous with light, it ain't scattering, the particles are too small. Either way, in this case, those particles are dissolved. So what's a homogeneous mixture? I'll paint you a picture you can hang on a wall. A solution like Kool-Aid, mister.
Oh yeah.
That juice that smashes the wall. You solve it, put a solute at solvent, watch it dissolve it. Now you have made your solution. Homogeneous mixture's what you call it. As long as it's not past saturated, no solute will precipitate its particles uniformly separated. Put salt in water if you want to make it. Call it all water if you want to name it. That's because this salt's dissolved. A homogeneous mixture, it's a solution. No problem, we got it solved. Looking at this mixture, if you know that they're distributed, this uniform solution, the mixture, it is homogeneous with light, it ain't scattering, the particles are too small. Either way, in this case, those particles are dissolved.
Alright, so what is the song all about? Yes, it talks about mixture. And what are the two types of mixture mentioned in the song? Yes, we have uniform mixture or homogeneous and heterogeneous as non-uniform mixture. Solution was also mentioned in the video and we will talk more about it today. But first, I have a few tasks for you. Now, kindly think of this one. If you mix sugar and water, what do you think will happen? Just take down your answers. Next, if you mix alcohol and water, what do you think will happen? Later on, you will watch a video about this. Now, if you shake and open a lid of soft drinks a bit, what do you think will happen? I knew that you have encountered this on the previous lesson. By the way, how do you feel today? Why do you feel hot or cold? And do you think is air important? Do you know the components of air and what it is used? Take down your answers. Now, kindly watch this video. So I have here 2 half-filled glasses of water. Then, of course, I have sugar mixed in the water and alcohol mixed in the water in the second glass. So, observe what happened. Can you still distinguish the components? Write down your answers. Well, can you still remember what type of mixture is Coke? Yes, write down your answer. Now, have you ever wondered how to make stainless steel and what it is used? Describe its components after watching this video.
Remember Superman? He could leap over a building with a single bound. He could also bend this with his bare hands. Bridges, skyscrapers, appliances, our lives revolve around this material called steel. Steelmaking usually begins with a pile of scrap metal. Using this 10-ton electromagnet, scrap iron composed of crushed car bodies, electric appliances, cans, and other steel scraps are gathered up. This powerful magnet is able to lift 5 tons of metal. About 83% of this scrap will be transformed into bars of steel. This metal is then dumped into a basket, which, by itself, weighs 32 tons. The basket can hold up to 60 tons of metal, and now they're going to melt the metal. This furnace reaches a temperature of 1650 degrees centigrade, hot enough to liquefy the metal. It is heated by 3 electrodes and by 4 natural gas burners. The contents of the basket are dumped into the furnace. Here, the pieces of metal come into contact with liquefied steel, which always remains at the bottom of the furnace. There's a reaction, and an aeration system draws out the smoke that's produced. At this high heat, the 60 tons of metal will melt in about 60 minutes. Then the cover is placed on the furnace. This liquid is composed of impurities, which rise to the surface when the metal becomes molten. At this stage, a workman draws a sample of steel to determine its chemical makeup. And now they make use of a supersonic oxygen lance. This lance blows oxygen into the molten steel, which reduces its carbon content, homogenizes the mix, and then speeds up the melting process. A ladle is positioned beneath the furnace. The molten steel will be transferred from the furnace into this ladle. The molten steel easily pours into the ladle. The ladle weighs 55 tons and holds 115 tons of molten steel. An overhead crane capable of lifting 180 tons carries the ladle filled with steel. Additives are introduced in order to obtain the correct steel tone. Here, the electrodes are taken out of the furnace ladle. A workman now opens the pouring nozzles of the distributor, equipped with 4 pouring holes. The molten steel runs into molds. It very quickly cools and begins to harden. Steel billets are produced in lengths varying between 4.5 meters and 10.6 meters. The billets are then cut to the desired length with a natural gas torch. A pouring identification number is marked on them with a wax crayon. The difference between a steel billet and the nearly finished flattened product is clear. Flattening of the billets remains to be done. Before flattening begins, billets are placed in the furnace to be reheated for 2 hours at 1095 degrees centigrade. Water jets cool the billet ejector. The billets are placed on the flattener, where powerful rollers compress them. This operation gives the billets the required shape and size. Water-cooled rollers crush the billets. Some billets go from a thickness of 12 centimeters down to 14 millimeters, while others reduce from 15 centimeters down to 19 millimeters. At the end of production, bars move along at a speed reaching 35 kilometers per hour. Once reaching their required dimensions, the bars must be cooled. This cooling bed allows the steel bars to cool uniformly. A total of some 400,000 tons of
All right. So, congratulations because you just have finished your tasks. So, what can you say about the video? Write down your answers. Alright, so a while ago I asked you, if you mix sugar and water, what do you think will happen? So the mixture of this sugar and water is what we call solution. Then, the water and alcohol mixture is one of the examples of solution. When you shake the bottle and open the lid a bit, what phase of matter did you see? Yes, you see bubbles, right? What phase of matter are the bubbles? Yes, that's gas. So, Coke or soft drinks are some of examples of solution. And of course, air is important. Without it, we can't breathe. Air is a solution. Steel, on the other hand, is also a solution. This will be later on further discussed on the next lesson, especially on our next meeting. But now, based on your activity, how will you describe solution? Yes, solution is a uniform mixture. And another term for a uniform mixture is homogeneous mixture. Homogeneous mixture has the same properties throughout the sample. It means that the substances mix thoroughly. For example, after stirring, they appeared as one substance. So you can no longer distinguish one component from the other. Now, think at least 5 materials that can be considered as a solution type of mixture and describe it. That's your first activity. Think at least 5 materials that can be considered as a solution type of mixture and describe it. Write down your answers. So, why do you think solution is described as a uniform mixture? Yes, very good. Because when you look into a solution, you cannot distinguish a solute from solvent. A solution is formed when one substance dissolves in another substance. Now, for your activity, kindly read. Is it a solution? Yes or no? If yes, describe it and explain why it is considered as a uniform mixture. So, first one salad, 2 juice, 3 afritada, 4 air, and 5 tea. Alright, 1 minute. Alright, let's check. So, number 1, salad is not a solution. Juice is a solution. A fritada is not a solution. Air is a solution, especially if this is an air without clouds. Then 5T, yes, this is a solution. So juice, air, and tea are solution type of mixtures. So why? Because you can no longer distinguish one component from the other. Alright? So congratulations! You just finished our lesson. Once again, this is Miss ELOISA LANUZA, your teacher. Goodbye!